All right, this is the extra examples from the section 2.4 notes. So we're looking at example 1, part B, and this is foiling because notice there's nothing between the two parentheses, but that means that it's indicating times. So 8 times 7 would be 56, and then 8 times negative 3i would be negative 24i. 2i times 7 is 14i. And 2 times negative 3 is negative 6, and then we have this I times I, so that's I squared. Now what we learned in class was that anytime you have I squared, that actually is a real number and it's negative 1. That's because of the fact that I, the letter in math, it stands for the square root of a negative 1. So if you square both sides, you get I squared equals negative 1. So this actually turns this whole term into a positive 6. So when I add my like terms together, 56 and 6 would both be real numbers. So they add together to make 62. And then negative 24i plus 14i would be negative 10i. We keep it like this because these are no longer like terms. This is a real part and an imaginary part, and that is what makes up a complex number. All right, so looking at D, D has something we're squaring, and then we're also subtracting here because we see this minus sign. So if we're going to do the squaring part first, just like order of operations, so we're going to write 3 minus 2i, and another 3 minus 2i, and then we'll bring down our minus parentheses for minus I. So we're going to distribute this out again. 3 times 3 is 9. 3 times negative 2i would be negative 6i. Negative 2i times 3 is another negative 6i. Negative 2i times negative 2i actually ends up being positive 4i squared. But because of the I squared, that's going to change into a negative form because I squared is negative 1. Distribute this negative sign. This is a minus 4 and a plus I. So my like terms for my real parts are 9, minus 4, and minus 4. So that's actually just going to be 1. And then negative 6i and negative 6i is negative 12i plus the 1i would be negative 11i. So 1 minus 11i. Okay, this patterns or powers of I, I'm going to cover completely in class. It's not on the exam, but it is something that will show up on your homework. I feel like it's easier to explain it in class, so I'm going to do that there. And then we already know that if you have an I, you actually have a radical. So we have to be careful because when we're dealing with radicals, we don't like them to show up in our denominators. So we have this situation where if you have an I in your denominator, you actually have a radical down there and it needs to be rationalized. What we learned in the last section of the radical information, which was 1.4, is that if you have a binomial in your denominator with a radical in it, we need to use the conjugate to get rid of that. The conjugate is the same exact binomial, except we change the sign in the middle. Okay? So we just change the sign in the middle. So notice that that negative 3 up front did not change. Whatever we do to the bottom, we also do to the top, so we're going to also multiply it by the same thing. So when we distribute this out, this would be 2 times negative 3 is negative 6, which my pen's acting up a little bit. 2 times I is 2i. 9i times negative 3 is negative 27i. And be careful here, 9i times I is positive 9i squared, which means that actually changes to a negative 9. So that's my top. Negative 3 times negative 3 is positive 9. Negative 3i would be next. Then we get a positive 3i because that's two negatives multiplied together. And then be really careful on this last one. This is negative 1 times positive 1. So that's negative 1i squared because you have an I times an I. And that's going to change to a positive 1 because of the I squared. So my negative 3i and positive 3i cancel out. And what I'm left with on top is negative 6 minus 9 is negative 15. 2 minus 27 would be negative 25i. And then on the bottom, I'm left with a 9 plus 1. So that's a 10. Now we're supposed to write our answer in what we call reduced format, and it needs to also be split into two separate fractions so that we have the real part and then the imaginary part. So if we split this, this would be negative 15 over 10 minus 25 over 10i, and then we can reduce. So divide both of them by 5 in the first fraction, that would be negative 3 over 2, and then minus, divide them by 5 again, that would be 5 over 2i. And that's my final format. Okay, I will do C in class, so let's talk about D. D does not have a binomial on the bottom, it's just an 3i, so it's a monomial. If you just have one term in the bottom with an I, you just need to multiply top and bottom both by I, because that will create an I squared in the denominator. So if we multiply the top by I, that makes negative 2i plus 6i squared all over 3i squared. Now the I squareds don't cancel each other out, because remember this is a binomial and this is a monomial, but they do change the sign of their number. So that's now a negative 6 and that's a negative 3. Because this has an I in it still, we have to split it into two separate fractions. So negative 2 over negative 3i minus 6 over negative 3. Notice the imaginary part should be at the end, so we're going to fix that, but this is going to be just a 2. That's this guy. And then the other one is positive 2/3 I, because it's a negative divided by a negative, just like this one is. So that is my final answer for that one. And notice my I is no longer in my denominator. It's just beside the fraction. For E, you do not want to distribute yet because you have these negatives under your square roots. We're going to actually simplify this first by talking about reducing this. The negative underneath the radical becomes an I, because remember, square root of negative 1 is I. And then we can take the square root of 25. So this is going to actually be plus 5i. The I is standing for, remember, that square root of negative 1. Times 8 minus, and this would be 6i. So now we can distribute. This is negative 24, and then positive 18i, positive 40i, and then negative 30i squared, which we know that'll change to plus 30. My real numbers are a negative 24 and a positive 30, so that would be 6, and 18 plus 40i would be 58i. Okay, for F, we need to do the same thing here. We do not want to multiply these together first. We want to pull the i's out first. Sounds very brutal. So this would be 6i times 7i over 4i. Now you can cancel an I with an I on top and bottom if there's no adding or subtracting. So this is actually 42i over 4, because I'm multiplying across right now. And I can reduce that by dividing both of them by 2. So that's 21 over 2 in the I. But we want to write it in standard form. So since there's no real part, we put a 0 placeholder in for that. So A plus BI, we use 0 if the real part is not there. So we only had an imaginary part. Okay, and then I will be doing A and B in class. These are just showing you how to use quadratic formula to solve these trinomials that don't factor and their answers have negatives under their square roots. So we're going to do the last 3 together on the video. So this is already set up in standard form, so it's ready for quadratic formula. So we let A, remember, be the first term, so that's 1. B is in front of X, that's 3. And C is the last term, which is 6. So this is X equals negative B plus or minus square root B squared minus 4AC all over 2A. Working out the inside, that's 9 minus 24. So this is negative 3 plus or minus 9 minus 24. Let's see. It's a little too late for me to do that in my head. That's negative 15 underneath there, all over 2. And then we need to pull the I out because of the negative under the square root. So that's going to be square root of 15 positive now with an I. Some people write the I in front. I like to write it at the end because I'm about to split the fractions anyways. So this is negative 3 over 2 plus or minus the square root of 15 over 2i. Now it's written in A plus BI format. So you don't have to split fractions when there's not an I involved, but when there is an I involved, we need to split them apart. Okay, so let's look at D. So this time A is negative. So A is negative 3. B, and my pen is not really wanting to work, so hang on just a second. So negative 3. B is 1. Having a lot of trouble with the PDF. It's not wanting to read the ink. So let me try that again. So B is 1. And C is negative 5. Okay, so X equals negative B would be negative 1. All right, I'm going to have to stop if this doesn't clear up, but right now it's writing, so let's see if we can get through this one. So negative 1 plus or minus the square root of b squared minus 4ac, and that's also a negative, all over 2a. And I'm having to write sideways because that's the only way it will register. So this is 1. This is negative 12, or excuse me, positive 12. Negative 4 times negative 3 is positive 12. Times a negative 5 would be negative 60. So that's going to be 1 minus 60. So that's going to be negative 1 plus or minus the square root of negative 59, all over negative 6. And we have an I to pull out, so that's negative 1 plus or minus. That'd be square root of 59 times I. All over negative 6, and we would split that, remember, into two separate cases. Which would be, now it's negative 1 over negative 6, so that actually makes positive 1/6, because it's a negative divided by a negative. Plus or minus, even if you divide it by negative, it doesn't really change it because they're both signs. It would make it minus plus if you wanted to be technical, but it's still plus or minus. And then that would be square root of 59 over 6, and then I. And this is not wanting to write that last part. Over 6, and then the i's on the end. Sorry about this. The pen is not liking my PDF tonight. So that's the answer for that one. I'm actually not going to be able to do E on the video because it's getting brutal how bad the pen is reacting to writing right now. So that will be the end of this video, and I'll make sure I get E covered in class as well.